All right, so I think this is recording. We're taking a look at skill packet 6 of complex numbers and the notes going through it. In 6D, we want to look at absolute value of complex numbers. Um, Recall that absolute value of a real number, if we have here is a number line, and if we just have, draw a small portion of the number line, that absolute value, one way that students can think of absolute value is the distance from the origin. So if we take the absolute value of 2, then, excuse me, of negative 2, here's negative 2, and the distance from negative 2 to the origin is 2 units, and the absolute value of negative 2 is positive 2, is one interpretation of a nice application interpretation of absolute value. Um, the absolute value of 3, well, because you're 3 units from the origin. So it eliminates direction. It just, and that's why oftentimes it's used as determining a distance. So we're going to do the same idea, determine the distance to the origin when we have our complex number. We know that if we have a plus bi, that we plot the point as a comma b, and if we're trying to find the distance from this point to the origin, we can use the Pythagorean theorem to help us. We can construct a right triangle that if we go to the right, we're going to the right a units. If we go up, we're going up b units. The Pythagorean theorem for a right triangle gives us the relationship between the legs and the hypotenuse. Um, ah, that the relationship is that if you the sum of squares of the legs is the hypotenuse. A squared plus b squared equals c squared, where c is the length of the hypotenuse. We want that length, so we take the square root of a squared plus b squared. So this distance from the origin to some point AB is the square root of a squared plus b squared. And notice that there is no I in that distance, that we're just using the real part and the imaginary part in a formula to calculate it. So let's do a few examples, and I think you'll find it pretty straightforward. So we've got this complex number, 6 minus 3i. Um, let's identify A, identify B, and use the formula that a squared, that the absolute value, I'm really struggling this morning, the absolute value of a plus bi is equal to the square root of a squared plus b squared. So therefore, this absolute value of 6 minus 3i is equal to the square root of 6 squared plus the negative 3 squared. Um, that that is equal to 36 plus 9, which is 45. I can simplify the square root of 45 to 3 radical 5, because I know that 45 breaks down to 9 times 5. The largest perfect square that divides 45 is 9. The square root of 9 is 3. So I know then that that's my answer, that the distance between, if you go out 6, down negative 3, the distance between this point and the origin, that distance is 3 radical 5. All right. Here, let's think of this as 0 minus 7i, that a is equal to 0, that b is equal to negative 7, that my formula for the absolute value of a plus bi is the square root of a squared plus b squared. So for this problem, the absolute value of negative 7i is simply 7, right? And if you think about that, it's pretty straightforward that negative 7i is just down 7 units. So the distance between this point at 0, negative 7 and 0, 0 is 7 units. All right. So I guess you didn't even need, if you picture what the graph looks like, you don't even really need the formula for that one, right? All right, and negative. This you've done for years. The absolute value of negative 12 is positive 12, and again in the complex plane, if this is my imaginary axis and this is my real axis, let's see. Let's move that over because it did say negative 12. Sorry about not making that very horizontal. Here's negative 12. Here's the origin and the distance between there, because remember that as negative 12 plus 0i, that distance is 12 units. Now if you want to identify a and b and take the square root of a squared plus b squared, it's going to be obviously be 12. Because remember, and the square root, it is a principal square root because it's representing, like I say, most of the time it represents distance, but this symbol, this radical symbol, is defined to be the positive square root. Now, of all the ones we've done, this one is a little bit more challenging because I don't have it in the form a plus bi to use my formula. So first I'm going to have to do the division of this complex number. So I have 3 minus I over 1 plus 3i. And our technique to do division of complex numbers was to use the complex conjugate of the denominator. So a common technique in algebra is to multiply by the number 1, and we're going to be clever in how we write the number 1 as 1 minus 3i over 1 minus 3i. So that helps us in the denominator to eliminate the imaginary unit, and we have a is 1 and b is 3, and a squared plus b squared is 1 squared plus 3 squared. Now, in the numerators here, I suggest that you do it in the form of a table, unless you've done the table so often that you're comfortable doing it in your head. You just want to make sure that later on you're not embarrassed that you make some silly mistake if you do too much in your head. Positive 3 and negative 3 cancel each other out, and I've got negative 1i, negative 9i, so I'm getting a negative 10i. So what do we have as our answer? That we've got negative 10i over, well, 1 plus 9, hey, that's 10. And so this guy is taking the absolute value of negative I. And that's just going to be 1, because think about where the plotting negative I is just down 1 unit. And the distance between where I is, negative I is on the complex plane and the origin is just 1 unit. All right. So hey, I hope that helps, and I will talk to you later. Bye.